Hello guys, welcome to Time to Read channel. In this video, I will explain about the types of sets. The first one is empty set. It is a set which has no element. It can be denoted by this or this. This set is also known as null set or void set. For example, the set of all integers between 1 and 2. In this case, there is no integer between 1 and 2. Thus, it is an empty set. Consider a is equal to x such that x is an odd integer and divisible by 2. In this case, there is no odd integer that is divisible by 2. Thus, it is also an empty set. And the second one is singleton set. It is a set which has only one element. For example, a is equal to 0. In this case, the set consists of only one element which is 0. Thus, it is a singleton set. And if you consider the set of all even prime number, the one and only even prime number is 2. And the third one is finite set. It is a set with countable number of elements. For example, a is equal to x such that x is a factor of 36. In this case, the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. Thus, it is countable. So, it is a finite set. Another example is b is equal to x such that x belongs to n whereas 1 is less than x less than 10. In this case, x belongs to a natural number and this natural number will be between 1 and 10. Thus, the natural numbers are 2, 3, 4, 5, 6, 7, 8 and 9. Thus, it is also countable. So, it is also a finite set. And the fourth one is infinite set. The set which is not finite, it means which is not countable, is called an infinite set. For example, the set of all whole numbers. In this case, the whole numbers will be keep on coming since the number in which it should stop is not defined. Thus, it is an infinite set. Another example is the set of all positive integers which is a multiple of 3. In this case, the positive integer of multiple of 3 will be keep on coming like 3, 6, 9, 12, 15, etc. Thus, it is also an infinite set. Here, I would like to add an information about cardinal number of sets. Cardinal number of sets is nothing but the number of elements in a set. The cardinal number of set A is denoted by n of A. For example, A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the n of A is equal to 10. Since the cardinal number of set A is 10. Now, the fifth one, equivalent sets. If a two infinite sets contains the same number of elements, then it is called equivalent sets. If A and B is equivalent set, then n of A should be equal to n of B. For example, A is equal to mathematics and physics, B is equal to ball and bat. Then n of A is equal to n of B, which is 2. Next, the sixth one, equal sets. If two sets contain exactly the same elements, then it is called equal sets. Otherwise, they are called unequal sets. In other words, we can say that if A and B are equal sets, then every element of A should also be an element of B, and every element of B should also be an element of A. For example, A is equal to 1, 2, 3, 4 and B is equal to 4, 3, 2, 1. In this case, both the sets contains exactly the same element. Thus, it is an equal set. Now the seventh one, universal set. A set which contains all the elements of other sets including its own elements is called an universal set. It is usually denoted by the symbol U. For example, A is equal to Mars, Jupiter and Uranus. Then the universal set is all the planets in the solar system, which is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Another example is if A is equal to 1, 3, 5, 7, 9 and B is equal to 2, 4, 6, 8, 10. Then the universal set would be U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the eighth one, subset. If you consider two sets A and B, if every element of A is also an element of B, then it is called A is a subset of B. We can write it as A is a subset of B. If A is not a subset of B, we can write it as A is not a subset of B. If A is a subset of B, then n of A will be definitely less than or equal to n of B because the set B will be having the more elements than set A since A is a subset of B. For example, 1 is a subset of 1, 2, 3 because 1 is an element in second set. If you consider 2, 4 is not a subset of 1, 2, 3 because 4 is not an element in second set. Now the ninth one, proper subset. If you consider two sets A and B, set A is considered to be the proper subset of set B if set B contains at least one element that is not present in set A. We can write it as A is a proper subset of B. For example, A is equal to 12, 24, B is equal to 12, 24, 36. A is a proper subset of B because 36 is not present in the set A. Now the 10th one, disjoint sets. Two sets A and B are considered to be disjoint if they do not have common elements. We can say in other words as the intersection of A and B is equal to empty set. Then it is called disjoint sets. For example, A is equal to 20, 22, 23, 24 and B is equal to 25, 30, 40, 45. Then the A intersection B is equal to empty set as it contains no common elements. Now the 11th one, overlapping sets. If A and B is a set and if both the sets have at least one common element, then it is called overlapping sets. A intersection B is not equal to empty set, then it is called overlapping sets. For example, A is equal to FIAS and B is equal to ANFHS. A and B are overlapping sets because it contains three common elements, namely A, F, S. Now the 12th one, power set. If A is a set, then the set of all subsets of A is called the power set of A. It is usually denoted as P of A. For example, A is equal to 2, 3. Then the P of A is equal to empty set 2, 3, 2, 3. And thank you for watching this video. And if you enjoyed the video and want to hear me again, be sure to hit the subscribe button and keep the bell icon in all.